Hello and welcome to my channel. My name is Fedor Sazanovets and I'm a senior .NET developer. This video is part of a series about solid principles and how to implement them in C# and .NET. Solid principles is something that every object-oriented programmer absolutely needs to know. And in these videos I will show you how to implement them in .NET and C#. For those of you who don't know what solid principles are, SOLID is an acronym. It stands for Single Responsibility Principle, Open-Closed Principle, Liskov Substitution Principle, Interface Segregation Principle, and Dependency Inversion Principle. Today we will talk about Liskov Substitution Principle. This principle states that if you substitute a base class with a class that inherits from it, a behavior of the methods inside the base class should not be changed by the inherited class. In any object-oriented programming language, this is a very important principle, because any variable of a base class type can be set to any instance of any inherited class. And now I will show you the importance of it by showing you a concrete example. In our previous video about open-closed principle, we have ended up with a solution that converts text from MD format to HTML. The first thing that we are doing to achieve that is converting text with a class called text processor. All that this class does is splitting the text into paragraphs and applying P tags, opening and closing ones, to each paragraph. We also have the following class, MD text processor, which inherits from text processor. It does exactly the same thing, but afterwards it also converts certain MD specific tags to HTML equivalent tags. We have a dictionary that takes MD tag as a key, and as a value it has a tuple, which has opening HTML tag and closing HTML tag. First thing that we do is count occurrences of each dictionary key, and afterwards every odd occurrence is replaced with opening HTML tag, and every even occurrence is replaced with closing HTML tag. And we only do this conversion if an even number of occurrences is found in the first place. And this is where we are replacing the tags. In our case, this particular class adheres well to open-close principle, because you can add new functionality to text processor class without modifying anything in text processor. However, in our case, this class does not adhere to Liskov substitution principle. And now I will explain a problem that may occur because of it. If you have a variable that takes the type of text processor, we can place an instance of MD text processor into that variable. And because both of the types have a method called convertText, we may end up with different value coming out of convertText than expected. For example, if a particular calling system was not expecting any replacement of MD specific tags and was only expecting conversion of paragraphs into HTML paragraphs, then what that system would get may not be something that the system would have expected. This can be demonstrated quite well with the help of unit tests. For example, we may have the following test. The input text of this test contains some MD-specific characters that are present in the dictionary. The variable that we are applying the test to is of the type text processor, the base type. And because of this, we are not expecting these symbols to be converted. However, if we place MD text processor into this variable, then our test will fail. Exactly as we expected, and this is because some additional processing was applied to the text, which system was not expecting. In our case, it's just a test, but in a real-life scenario, it might be part of the working system that calls this method. And because of this, we have changed our logic. Our text processor class has not changed at all. However, in our MD text processor class, there's a new method. And now, when we're inheriting from text processor, we are not changing its convert text method. Instead, we have created a brand new method called convert MD text. Convert text is not mentioned in our class at all. And this means that this method is still accessible to us, but its behavior is not changed in any way at all. Our test has not changed at all. But if we run it now, our test will pass successfully. And now let's summarize the importance of Liskov Substitution Principle. This principle is needed so you don't unintentionally introduce bugs into your system. So the behavior that your system receives is still 100% the behavior it expects.